Now let's delve into the code so we can see how the PIR sensor alarm circuit works. So starting at the beginning, we've seen this before, we import the GPIO library, and that allows us to interact programmatically with the GPIO pins. Then we import the time library, and that allows us, of course, to sleep and introduce delays in our program. Next, we have GPIO.setWarnings false, and again, this just suppresses any warning messages that we need not be concerned about. Then we declare a couple of variables. So first we have the PIR pin, and that's equal to 7. And if you remember, the PIR pin was connected to pin 7 on the Raspberry Pi. Then we have the buzzer pin equal to 11, and then we do the GPIO.setMode, GPIO.board, again because we are referencing the pins by their physical locations. Next up, we set up some of those GPIO pins. So first, the PIR pin, we set that up as an input. We set the buzzer pin up as an output by setting GPIO.out, because we'll actually be sending an output signal to the buzzer for it to make a sound. And initially, we do GPIO.output buzzer pin, sending a low signal to our buzzer pin, and in that way it will be off initially when our program first starts. Next up, we define a couple of functions, and we haven't seen these thus far in our programs, so now we are gradually building in complexity. And the purpose of this is because I wanted to illustrate a different way of handling interrupts using our Raspberry Pi and Python. So the first function is going to sound our alarm. So the name of the function is soundAlarm. It takes one argument, which is our PIR pin. And in Python, when we define a function, we use the def keyword, and that's simply saying that we're defining a function. At the end of the function name, we have a colon, and what follows next is the actual body or content of that particular function. So within the function, the first thing we're going to do is print sound alarm. So that's going to show up in our shell. And then we're going to do a GPIO.output, setting our buzzer pin to high. And that is going to turn our buzzer on, and that's when you heard that audible sound coming from the buzzer. We keep this going for about 2 seconds. So we call time.sleep, passing in the number 2. And after we're done, we want to turn off the alarm. So we call the turn off alarm function, passing in our PIR pin, and that conveniently jumps into the next piece of code. So the next function that we have in our program is turn off alarm. Again, it takes PIR pin as an argument. And within here, essentially, we turn off the buzzer. So we do a GPIO.output, buzzer pin GPIO.low, and that essentially sends a low signal to the positive pin of our buzzer, and it's going to turn our buzzer off. So you're no longer going to hear the buzzer making a sound. So those are our 2 functions. Now the main important piece of this program actually is the very last line of code. What this is, it's a way that we can introduce interrupt handling in our program in a more efficient way, in that we don't need to poll constantly to determine if the PIR sensor pin is high. So we do this by using event detection. So the GPIO library affords us this ability, GPIO.add event detect. And basically here's where we specify the particular pin that we want to detect an event on, whether the value of that pin is rising or falling or both, meaning the change that happens. And if you recall, for the PIR sensor, the signal pin goes from low to high when motion is detected. So by indicating GPIO.rising here as our second argument, we are saying anytime our signal pin or our PIR pin detects a change from low to high, which that is when motion occurs, we want to execute this particular callback function. And the third argument to this add event detect function is callback equal, and we pass in the name of the function that we want to call, which is sound alarm. So essentially, what's going to happen here, once we have added that event to our pin, anytime the pin goes from low to high, or in other words, a rising GPIO, that particular scenario happens, and the pin goes from low to high, this sound alarm function is going to be called. So we jump into the sound alarm function and we execute this piece of code, which prints out sound alarm to the shell, turns our buzzer on for 2 seconds, and then turns it off. And then our program continues, and it simply listens for when the motion is detected. Another point that I wanted to highlight is that this piece of code here runs in its own separate thread. So Python has the ability to have multi-threaded programming. So if you had other parts of this program, what would happen actually is once an event was detected that the signal rose from low to high, this piece of code or the sound alarm function would be called in a separate thread to your main thread. And that's pretty interesting as far as how interrupts are handled, and it allows a lot of efficiency, and you can do other things in your program without having to wait or block or pool, and you can write more efficient programs that utilize resources and memory in a more efficient way. So hope you enjoyed this. It was just to illustrate how we can do interrupt handling and how we can detect a change, whether it be rising or falling or both scenarios from any of our GPIO pins, and then use this subsequent information to take action.